All right, guys, this is the beginning of chapter 12. The title for this is going to be called Earth's Atmosphere. Let's take a look at the notes. The title to this is Earth's Atmosphere. Anything written in white is equal to notes. All right, so the Earth's atmosphere is a mixture of gases with some suspended solids and liquids. Now, the majority, contrary to what most people think, the majority of the atmosphere is made up of nitrogen and not oxygen. There's about 78% nitrogen, 21% oxygen, and trace amount of other gases. There's also water vapor, which is about 0 to 4%, depending on how humid it is in the atmosphere and how much water vapor is present. And so water vapor varies a little bit. We also have some suspended solids and liquids. Water vapor would be one of those liquids that could be in there. Also, some of the solids like dust, particulate matter could be located in the atmosphere too. If you were to look at a radar, you could actually see some of the suspended solids on the radar sites, like the National Weather Service sites. They're little dots that are on the radar. Those are those suspended solids, like the dust that picks it up when it's on clear air mode. Okay, next slide talks about smog. Smog is dust and gas from cars that mixes with the oxygen in the presence of sunlight. Smog is definitely a lot more in abundance on the West Coast cities like Los Angeles, San Francisco. The reason for this is there's a little bit of an inversion, and this is just when it's a little bit more stable of an atmosphere, and the smog has nowhere to go, and it kind of sits in the city until you get some sort of frontal boundary, like a cold front that comes through and cleans out the atmosphere, and the smog is able to either evaporate or go into different parts and move into different areas of the country. There is some smog in the East Coast cities, but again, it's not as stable as an atmosphere in New York City and Boston and Washington, D.C. So the smog that is in these cities tends to go away in a short period of time. So the atmosphere is composed of 5 layers: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The troposphere is the lowest portion of the atmosphere. It is about 75% of the atmosphere, so a good portion of the atmosphere is located in the troposphere. Life is in the troposphere. We live in the troposphere. And right above it is the stratosphere. The stratosphere is the layer that contains the ozone layer. It's about 24% of the atmosphere, so that gives you about 99% right there. So most of the atmosphere is pushed down in the first 2 layers. Above the stratosphere is the mesosphere. The mesosphere, it's cooler, and this is the area where if you had a meteorite that was coming towards Earth, if it was small enough, it would burn up in the mesosphere and would not make it down to the surface of the Earth. Above it is the thermosphere. The thermosphere contains the ionosphere, which we'll talk about in a little bit, and there aren't many molecules at all there in the thermosphere. And above that is the exosphere. The exosphere is very large. This is where the space shuttle is located, and many of our satellites are located up in the exosphere, or just above it. All right, so the lowest layer, the troposphere, that's closest to the ground, contains about 75% of the atmosphere. The tropopause is the line where usually the clouds stop because temperatures are starting to get warmer, so the air will not rise from this level. You can also see Mount Everest is at almost to the top of the tropopause, but that's the line between the stratosphere and troposphere, right around 26,000 feet. And also commercial jetliners are located up at the top of the troposphere. They fly in something called the jet stream. And if you're in the jet stream and you're going with the flow of the jet stream, which is just a condensed area of winds, you can get to your destination a lot quicker than going in the opposite direction of the jet stream. So people flying from like California to New York City Usually takes about an hour less than going from New York City to California. And then above that is the stratosphere. The stratosphere contains the famous ozone layer. Weather balloons go up to that level, and when we were in the Cold War era, we had spy planes that were up in this area that took pictures from this level. All right, we also have the ionosphere. The ionosphere is a layer of electrically charged particles in the thermosphere layer. AM radio waves are bounced off the ionosphere to be transmitted from one portion of the globe to the other. Also, northern lights are formed here. The northern lights are those famous green-blue glows that are given off in the northern latitudes due to its reaction with the sun with the ionosphere. It gives off the blue-green colors. So when you have air, there is a mass to it. It creates atmospheric pressure. And what happens is the gas at the top of the atmosphere pushes all the gases lower in the atmosphere closer together and making it more dense. So there's a lot more pressure down at the bottom of the atmosphere than there is up in the top because there's not as many air molecules that are up there. So down below, there definitely is more pressure. So you hear meteorologists, when you look at their weather maps, that talk about high pressure and low pressure systems. The low pressure system forms because what's happening is the air is rising in low pressure systems. So it is less dense at the surface because the air molecules are going up. So that makes it lower pressure. In a high pressure system, you have cooler air that's sinking. So you have more air molecules that are sinking towards the surface, which makes it a higher pressure, hence the high pressure system. Also, people that climb like Mount Everest, there are less and less oxygen molecules that are available in the air because most of them are at a lower level, so people have trouble breathing there. You hear people that they don't survive on Mount Everest because of a lack of oxygen. Several people have died from the lack of oxygen that's up there. So you need to make sure that you have some sort of oxygen-saving device because it's very tough to climb up there. You can lose your breath. Same thing with if you go to the Colorado Rockies, you go to Denver. Sometimes it's easier to hit a home run because the air is less dense. So they even put more wetness to the ball or humidity to the baseball so it doesn't travel as far in Denver. Then finally, in the stratosphere, we have the ozone layer. This protects us from the harmful ultraviolet radiation from the sun. Now, there was a problem back in the 80s when we were giving off something called chlorofluorocarbons. The chlorofluorocarbons were coming from aerosol bottles, they were coming from refrigerators, they were coming from air conditioners, and these CFCs, the chlorine that was in there and the fluorine and some other particles that were in the CFCs, were reacting with the ozone, which is just three oxygen atoms put together, and they were reacting with it and they were combining with the ozone and breaking the ozone apart and forming it into a different molecule. So it was creating a hole in the ozone layer, and that was causing more ultraviolet radiation to reach the surface. So they were afraid of people getting skin cancer and different skin diseases. So the world basically joined together and made sure that they would not be using chlorofluorocarbons anymore. And most countries don't use it anymore. There's a few third world countries that do use them. But in general, the problem should be eradicated over time. If you look at the picture there in 1982, the hole wasn't that bad because we were just starting to use the chlorofluorocarbons. But now we have a pretty big hole over the area of Antarctica. Not really much in people there, so it doesn't affect anybody. Well, it could affect the people that are there, but it doesn't really affect people in other areas. However, they think that this hole will start to get smaller over the next 100 years or so once the chlorofluorocarbons finally get cleaned out of the atmosphere. All right, this ends the PowerPoint presentation for the Earth's atmosphere, and I hopefully will see you tomorrow with your notes. Thanks a lot.